Hello people, welcome to Pivo, welcome to my presentation where we're going to talk about integrating software, about making contracts between services a palpable, real thing, a thing that programmers will have to abide. This presentation will mostly be me talking, intersected with several examples of a small project I made to demonstrate what can be done. And this project will also be on GitHub, so which link you will get on the end of the presentation. So let me start. Most of you have worked with services in some way or the other. I hope everybody here knows what's a service. It's a pretty nondescript word, any really application. How many of you have ever worked with something that has multiple services, like microservices, service-oriented architecture, something like that? So, like half the room. Great. Well, those ways of combining services depend on your architecture. For this talk, we're not going to be bothering about that too much. It's pretty architecture independent. As long as your service has some kind of an interface, has some kind of an interaction with other services or with front ends, this is going to be at least a little bit useful for you. I'm going to go technological every now and then, going deep, and but the principles should apply outside of these examples as well. This is going to be in Python, but it applies to Node, to PHP, to C#, Java. All of them have similar tooling in their own ecosystem. So, who am I? Why am I talking to you today? I'm a team lead at kiwi.com. I work with a team called the Team B. I lead that team. We work with services that we've spread to make booking at Kiwi and managing your booking work much more fluently. We try to break it down so you can access it through multiple services. So you can use your browser for front-end, mobile applications. We have a phone interface where you talk on your phone with the bot, which will then call our APIs. We have an interface through CS. There are multiple ways that our services need to be used by other parts of the infrastructure. I've been working at this for some time now, but before Kiwi, I also worked for edX and the Texas University through a small company in Croatia called Extension Engine. All of them were Python projects with a little bit of Node thrown in at Texas. And they're all being sprawling and using open source a lot. The problems usually repeated. So the solution to many Pythonic problems are usually types, which nobody who codes in Python likes. But what can you do? So I work for Kiwi, as I've mentioned. You've probably mostly heard of us. We're a travel company that's focused on technology, that's focused on solving the problem of combining multiple flights technologically, solving it via software. Our vision is to make traveling simple, accessible, to make interlining easier, and to make it comfortable. We work with Python and some other technologies sprinkled in, and yeah, we try to make travel better. So, I'm going to talk about services. I'm going to talk about how communication, when you're talking about code, is best done in code. Nobody likes to hear a vague description of what they need to do, because then they don't know what the other teams will be doing and how. So communicating code doesn't work that well. Sharing it programmatically is, I think, the solution. It protects you from misunderstandings. It protects all those services consistent with each other and makes cooperation between them great. If you have the same class in two different applications, then it works exactly the same. And that would be great if it would be that easy. Maintenance of software is easier when the code itself is shared. So, how are we going to talk about it? First, I'm going to describe some base points. What's schema? What's an API? How do they work? We're just going to gloss over it fast. I'm going to mention what API first means, what going with schema before even writing code would bring you. I'm going to mention what kind of tooling we use at Kiwi, what kind of tooling I used in the project. I'm going to mention how schema should be enforced or it's made useless because it will be outdated in a week. And if it's enforced, how great that makes your application, how great it makes the whole concept work. I'm going to mention how we structure services, how I'm going to structure those services in the demo. I'm going to show how we share schema, what's the approach of it, how we treat schema as a library, as a part of our code rather than some documentation a project manager wrote. And at the end, I'm going to show it all work together and make some conclusions about it. The examples are done in Python using Connexion, which is a framework built on Flask. It uses Swagger, today called OpenAPI, to build that integration of schema and application. I'm going to use birds as a motive for the demo itself. We're going to be making two applications, one for having a category for bird watching, the other one for registering ownership of a bird. They're going to be completely trivial in logic itself, but they're going to be a way to display how a same resource, a bird, can be used in two completely different ways. It's a made-up example, but it's a realistic use case when you think about it in different applications. If you can use this example of birds and just switch birds for a product, for invoice, for an invoicing application, for inventory of some shop, it goes very similar. In our case, for a booking, for a flight. You can put any spin you want on it and the examples should still hold. So what's an API? Application Programming Interface. Everybody talks about it all the time. It's used in the context of web most often, although it doesn't have to be. It's a way somebody else accesses your code, accesses your product, your application. What's often neglected is that API itself is a product. It needs to be treated as such. It needs to be treated as something you're selling, as something you're making, and that needs to be quality. Because tomorrow, your API will be your product. You will start selling it to some partners. You will start making different implementations that, if you don't treat it properly, will just melt away and you will be there with a lot of spaghetti code. Schema. Schema comes from the Greek word schema, surprisingly. It means shape, or more generally, some kind of a plan. And it's a very general word, but in the basis, it means a plan of what we're doing, some idea, some blueprint. We should schema almost everything we do in our professional life. As you grow as a programmer, as you develop yourself, you learn that maybe stopping and waiting before writing code is a good idea. You wouldn't let a doctor figure out your operation as he goes. You shouldn't do that to your code either. Plan first, do after. Make an idea, shape them concisely, write them down, and then structure your API to follow that. That means that sometimes we'll have to stop, take a couple steps back and watch over the whole system, look over it and figure out how to do it better. But that's just the part of development. And making schema first will prove itself much more beneficial when you have multiple teams or multiple departments or both working on some project. Because not everybody can wait for you to figure out what you're going to do through writing code. So, adopting the API first approach would mean that you would figure out what your code will do, write it down, scheme it out, then write the code. The point of API first is to get that feedback from other implementers, from people who will use your schema, from people who will implement it, your front end, your mobile, your services, It will also require getting some clients to give real feedback, to figure out and think if they can use this schema in their application. It will also separate what and how. You will try not to think about how you're going to write the code, but what it's supposed to do. So you will not put there elements that are useful for your code writing, but elements that are useful for your business logic. And that's an important principle with schema. It sets up your application to serve business rather than the other way around. And I'm not advising against being agile, flexible, or whatever buzzword is popular these days. I'm just advising against being reckless and doing code before we think about it. So, I mentioned this Open API. Open API used to be known as Swagger. It's a schema language, standard interface, some kind of a way to express what you're writing down. Most of us have tried to adapt something similar, if we've ever tried, that you cook on your own. Then you discover that there's this great standard. It's language agnostic, which is great. You don't need to know Python to do it. You don't need to know anything. And once you learn it, you have the common interface that is shared by the whole community, that's shared by anybody who wants to implement this. And that gives you a lot of power. Having a structured way to write down your ideas and then implement them with software will unlock so many doors to us, it's ridiculous. We'll get to that part yet. But I'll explain some basic concepts of OpenAPI now, of Swagger actually, as this is written in Swagger, but it's almost the same. The principles carry over. So there are these parameters, paths, definitions, metadata, headers, references. Can sound a bit daunting, but you'll figure it out quickly. Who here has some experience with web development, with web in general? Doesn't really have to be anything intimate, just basically you know what a request is, what post is, what a response is, almost everyone. That's going to make it easy to follow. So, this is a compiled schema shown in my browser. And what's the point? The point is that here we have an application on the internet, /birdwatchers, and that's documented via the base path. We also have all kinds of things here, what I mentioned, definitions, parameters, etc. Let's go through them one by one. Consumes means that our application will communicate in JSON. Easy enough choice, very standard today. Definitions are objects we're going to be working with in our code. In this case, it's the bird and the nest. Completely arbitrary choices here for the demo. A bird will have some properties, and it will be an object. Here we're getting to the part that will carry on to code. We'll have some object. In Python, it will be a dictionary that will have some properties that are going to be defined ahead. Remember, we're defining this before we even start with coding. We don't want to code before we know what are we going to be working on. We're going to be working on birds. They will have some kind of an object. They will have multiple properties, like a name and a wingspan. Those properties will be describing some unique name associated with the bird, then some wingspan of that same bird, and it will also be connected to a nest. And that's a reference to another object, to nest, right under here. It also has some description, properties, some terrain, type. It's pretty common sense once you start reading it. It comes naturally, writing the schema down to describe your idea. The terrain can be one of the enums that are all strings, etc. We don't need to go into more detail for this. Info is some kind of a metadata. It doesn't matter that much. It contains the contact for your API. And that's the thing. Your API should be defined in this schema, and that includes ownership. Many of you, if you work with services, have encountered a mysterious service that works on some place in the code and nobody even knows who worked on it. Things like that should be documented. Versioning, although versioning APIs is not always a good idea. Some parameters. Parameters are inputs to our schema. It means like, what are we ready to accept? What are we ready to work with? In this case, we'll be selecting some birds by their bird name. Simple enough. A string with a defined length. And the idea is that this schema will be done by people who make these decisions, make some business decisions. And if they want us to be able to select birds by their nest type, well, they should write it. Then it's easy to develop for it once you know that's a parameter that you can select with. There are some paths. Paths are pretty much API endpoints with methods defined and their own parameters when needed, although this is just a reference to the bird name that we've mentioned already. They have an operation ID, and this is where code integration comes. This is something specific to Connexion, and it just says that when this path gets called, this function gets called with the parameters provided. So it connects to the code and is readable here in a human readable way, while in the code it glues everything together and just performs our function. There are also responses in JSON. Schemes, we're going to be using just HTTP. This is the implementation detail of our API. And tags are just arbitrary display of how it works. In this case, birds. We're just tagging everything with birds.
So as we discussed it earlier in detail, I think it's worth also mentioning the Swagger version, that this 2.0 is already kind of deprecated.
Yes, I mentioned. I'm working in Swagger on these examples. Although today OpenAPI has replaced Swagger. It's the version 3.0. And yes, if you're trying something new, start with OpenAPI. This example is in Swagger, mostly out of inertia, but all the tooling supports 3.0 and it's very similar. You can check it on your own. We passed the example.
So even Connexion supports 3.0?
Yes. It's a recent advancement, actually. They upgraded, I think, last year. So, what's the tooling? What's the tooling that using OpenAPI or Swagger will let us? It's the UI. We're going to see it in a bit. It's all the online resources you have. A lot of the schema that you write can be validated for good and bad ideas. And as that, will let you know, hey, maybe I shouldn't define these resources like I did. And you didn't even start writing code yet. It has a large community, a lot of interactions there, a lot of guides how to do it properly. And you're going to see that we're using Connexion, which includes Python code in the package. You can also put schema to YAML or JSON. It's defined in YAML in the example. I've shown you a JSON version because it's already compiled, but we'll get to the YAML example in a bit. Why YAML? It's more humanly approachable. It's less programmer noise. There are no brackets. There are no programming constructs. It's mainly opinion and taste. For us, we use tech writers sometimes to edit it, and other people who all have limited programming skills. And for them, it's proven to be more approachable to use YAML. I personally have no preference in it. So, let's get to Connexion that I've been mentioning. It's a framework on top of Flask. Flask is a micro framework for Python HTTP. It automatically handles requests based on your schema. That means that you don't have to worry about validation. You don't have to write checks of your inputs or your outputs. Connexion does that for you. And it describes the API in the YAML format. The schema described in the schema is transcribed into code. Flask is a micro framework in Python. Light, fast, doesn't have a lot of opinions. You add whatever you need. You work with what you can. It has rich tooling, a lot of flexibility. It's a great thing to use if you're doing many smaller services because it lets you do whatever you want. And yeah, this architectural choice is there to allow many smaller, flexible services. It allows for many different iterations on our code. Little bloat and as much customizability as you want. It's very simple, and that makes it a great choice for a lot of different services. So, Connexion enforces schema. That makes it priceless in this whole structure because that schema is then enforced. It's a plan that has to evolve as you write code, as you advance. And as that plan evolves, the schema is updated as its own item. Many of you have worked with something written by another person who has fixed several bugs but forgot to mention it in the documentation. So the documentation describes a certain thing, but then it behaves differently. When you enforce it programmatically, when you enforce your schema, your documentation, like this, that cannot happen because the logic is pulled from the schema. If it doesn't pass, it doesn't work. All your tests will fail because you didn't update the schema. Your inputs don't function anymore. It's great because then all the parts of your machinery will have the same source of truth, and you will not have to copy-paste it yourself. So, the app, as I mentioned, is written in Flask. Here we have the create app code. You don't have to worry too much about it, about whether you understand or not. Basically, we create a Flask app, which is imported from Connexion. Then we import the module. This does not have to be done, but for the sake of reuse, I've created both of the apps the same way, supplying the package name. We also import some basic schema here. I will get to that in a bit, but this is a part of our processing to combine several schemata together. Then you just pass the prepared schema into the Connexion app. We validate responses and use strict validation because it has proved to be generally better. When you force yourself to be strict on these things, then you don't have mystery bugs appearing because your schema was relatively flexible and a bug appeared due to several different factors. And here we use a Rusty resolver, which just means that all the applications will have automatic names if you don't explicitly set them down. We don't really care about that too much. It's mostly boilerplate. Now these call functions in handlers, which is just a name we choose. And in this case, I'm going to go to bird keepers. Excuse me. To birds. Not bird keepers. I meant the bird watchers. To birds. Here we have a data layer baked in with a normal list of birds, a dictionary, some randomly picked birds, and we'll have a function that will return all the birds, taking no inputs, returning a dictionary of different values in the list. And we'll have another one that says get one. And it will try to get one bird, and if it isn't there, it's just going to create an error. So this is all the code we'll have, and it's there just as an example to show how our schema will interact. Also notice that here we have no necessity to validate the bird name. We don't have to check if it's too long, too short, etc. All that is defined by Connexion from the schema, and it's done before bird name even comes to our function. So, I've mentioned schema sharing. What's that? What's the reasoning behind that? We like to use code to create schema from some main repository. We call it OpenAPI core. It doesn't matter how you call it, but basically it's a module where we keep all our common objects. In this case, we keep the bird and the nest there. So all our applications that use the bird or a nest use the same schema. They use the same section of code to describe those two. And that gives us a separate repo, a separate module, where we keep this business logic, these business items. And that lets you have full ownership of that logic, of that API. So when somebody decides that they want to record prices along with owned birds, somebody else will have to review it from a business perspective, from a perspective unrelated to code. And that assures you that the contract makes sense, that nobody will implement it in their own part of the API. We execute it by bundling the schema files together and parsing them as a single entity. There are several approaches to this. One of them is pre-processing. There are tools out there that allow you to bundle the schema together according to reference links from different files. That's great, but it's complicated to implement. It requires a separate step as pre-processing to prepare the schema, to bundle it, to send it as your product. We use formatting guidelines. We glue the code together by following a certain guidelines, a certain setup, and when we format it in that way and gluing it together, we just generate the schema out of the files. The best approach is the full link expansion, which would parse all the parts of the schema during reading it, so there would be no need for pre-processing. Unfortunately, it's still not there, but I've heard it's in development and it should be something released middle of this year. So, how does it look, the pre-processing? Schema loader, basically it navigates through the directories we allow. In this case, it's the schema directory with its definitions, parameters, and tags. All the items I've mentioned already. Navigates through them and glues together the directories, forcing them into a big schema. This lets us use that schema with definitions that are not a part of it right away. So in paths, my birds, we use the definition of an owned bird. And that's a definition of a bird, which is not part of this schema, as you can see. But it's a part of a different module, and in production, it would be a part of a different repository, of a different owner, that we would just be reusing here. And whenever we would use a bird or a product in code, we would be using this definition defined by a third party internally, but not in our hands. So it would be shared through all the services we use, through all parts of our ecosystem. In the future, as I mentioned, full link expansion would be great, where you would name the module itself without any pre-processing. It's being done by Connexion. There are several different hacks to do this. We're just using one of them. Or you can do the pre-processing with Spezi. It's a great tool that also can check your schema for any bad habits, for any problems it has. It's basically a linter for OpenAPI. Then, in the end, while combining all these services, we use the same base schema to create different products. We bind them via code integration, so changes are not easy to make. Big changes are not easy to make. Smaller changes are all synced, and they can be audited much more carefully. We can rest assured that if we want an element to be expanded, it will be expanded in every single application. And that makes the terminology used to write this schema match the code itself. And that allows us to run these two services. For some reason, it doesn't seem to be working properly. Okay, moment. There. So we're going to run our two applications, completely separate units of code, and they will both be using the same build schema that I've demonstrated, the one with the bird and the nest. Pulling out from the definitions, which means that by using these two, we first get the benefit of having an UI built for us automatically. There's no code but the schema used to create this, with contact information, versioning if needed, and an interface to work with this. I will zoom it out so it's easier to follow. Okay, so the whole API is built with automatically generated documentation that also allows you to try it out. And in this case, we try it out to get a bunch of birds from the database. Then we can request a single bird, copying exactly the element returned by the API. And remember, the schema contract we've written defines the bird name exactly. So copy-pasting anything or using it programmatically is done without making changes to it. You're trying to work with as much immutable data as possible. We set the parameter of the bird name, and it returns us specifically that bird in a already written shape of the object. And we can use that object to use our different application on port 81. Where we have the bird keepers who accept a specific list of values. What Connexion does to you and the Swagger UI, they allow you to define some example values as well. In this case, we can automatically fill a different default value. but we're going to use the output of the different API and just pass it right in and set ourselves as the owner, sending it out. And this allows us to work with both of the APIs, with both services, using the same language. And in the case, we decided that we want to edit it and change the schema of a bird to add what? Any suggestions? Let's add nest size. Well, not nest size. Or maybe, yeah. Nest size. To the schema and use our database. First things first, these are all optional properties, so they don't need to be defined there. That's the suggestion for building an evolving API, would be to add things like this, so the current applications would work without a problem. Then we can add it to our so-called database, not bird keepers, bird watchers. Adding sizes to several of the birds. There, and then I made a copy pasting error. As we edit the schema, it's automatically validated for us as well, so errors just crash early rather than later. Okay, the applications are reset. Now in the list of birds, we'll have the nest size with several. And in this case, after refresh, on our other application that we didn't even touch, the example of the nest size is already there. It automatically gets added to the schema for both of the apps and to the defaults and examples for both of the apps. Thus, when we decide to add a new feature, it gets propagated through all the APIs we have in our architecture, in our environment.
Is it because you share the code, or do you do that pre-processing?
The pre-processing is done in the app. So yes, it's a module. We import the base schema as a module that we inject over the schema of each application. So each application has the ability to have its own code, but it pulls from the same business logic, business items, so to say, that we work with. Rather than have everybody define their own way to see a flight, we force everybody to use the same object. And if they need some other features, they need to push them upstream before they can change the contract of other applications. So, the conclusions of all this demonstration is that if we do the schema first, we make it an important part of the product, of the whole process. It forces things via code to self-validate. It forces them to be consistent, and it lets you use a lot of tooling and a lot of reuse that will just echo through the whole code base. And as you work, you will notice that a tight interface will pay for itself many times over. The moment you allow a user to use your data immutably, you have a great win, because then you know that there was no interactions needed to make your two services work together. How can you start? How can you start doing this? It's relatively easy. You can just fork this repository, play with it a bit, and start your own project. The thing is, if you don't work in Python, these tools exist for different applications. If you don't like OpenAPI, there's also JSON schema and other scheming languages. There's a lot of different ways to express yourself, and depending on your technology, you may not be using exactly this approach. But the process is the same. The process should be separating the schema, separating the logic, and versioning it, protecting it from everybody just changing their own ideas of what your product should be. And then I also linked here a great article from Phil Sturgeon, how to get the schema from an already existing object. So from an already existing application. It will allow you to adopt this, if you decide to, easily by tracing your code and allowing you some other tooling to just retrospect your application and get its schema now. Then you can slowly start validating it and have a much better documentation and interface of your product. This is the link to the application on GitHub. These are some keywords that I've mentioned if you try to research it on your own. And these are some useful links if you want to research more about this. Thank you for your attention, and let's get those beers.